The previous video, we saw that our mean value was pulled because of something called an outlier. Let's understand the outlier a bit better before going into trying to solve this particular sum in some other method. So basically, this is a small dummy data set where it's a small party or a gathering of a few employees or people. So there's Mr. X who has an income of say $1,500. There's a Mr. Y who has an income of $1,200. Now there's this giant who comes in, Elon Musk, and has an income of $1 billion. Now, just because Elon Musk is a part of this particular data set, the mean approximately jumps to $333 million. If you just consider the two people on the top, the mean would be somewhere around 1350. But just because Elon Musk is a part of the data, the mean approximately jumps 10, 20, or 100 times. So that's what an outlier does to your data. So let's look at the definition before going into the formulas. So median is the middle observation after the observations are arranged in the ascending way. In this way, it is not affected by the outliers. Now, how does it do that? So let's just look at the formula for now. So median is n plus 1 divided by 2. So if you have three records, the middlemost observation will be 2. That makes sense. First, second, third. Second is the middle value. Now, what happens when the values are even? So say if you have four records, what do you do then? What is the middle value? 2.5. Well, there is no 2.5 record. So what do you do is n by 2. N by 2 is 2. So 2th observation plus 2 plus 1, that is 3, and the third observation. So you take in the values of the second and the third observations, considering that there are four observations now. So you take those two, add the values, and then divide that value by 2. Having a look at these particular formulas, let's understand them better with the help of an illustration. So coming back to the very same example that we couldn't solve with the help of mean, we could see that the mean was somewhere around 3,300 million. But if we consider the median formula, we are getting somewhere around 1,500. Now, how is that? So if we go on to arrange this particular data set, 1,200 will be on top. After that, we have 1,500 and then the 1 billion. Now, there are three observations. So going back to the formula, we can see that the formula is n plus 1 by 2 because the number of observations is odd. So over here, it will be 3 plus 1, that is 4. 4 divided by 2 will give us 2. So that is basically the 1,500 value that comes in the middle. You understand what happened here? We came down from this to this, which is the actual middle value that should have been here. Just because of the outlier, we are getting a different value. So median helps us get the middle value. Let's look at a different example for median so that we have a better idea. So we have four families that are going to meet in a restaurant, and the manager asks the host, so what are the number of people per family on an average that are going to come, so that he can make the arrangements of the table accordingly. So the host recollects that family 1 has 3 members, family 2 has 4, family 3 has 5, and family 4 has 5 again. So now he can't say that, okay, you make 3 chairs here, you make 4 there. So he gives you, so how does he give an average value? So the okay, so let's just do the mean calculation here. So the mean should be 3 plus 4 plus 5 plus 5, that is 17. Now, what is 17 divided by 4? It will be 4.25. Now, you cannot have 1/4 of a person, right? Coming back to the median over here will be the second value plus the third value divided by 2. So 4 plus 5 divided by 2, that is 4.5. This seems to be wrong as well. And Why is that? Because we cannot have a half a person sitting in one table and half of a person sitting on the other. The concept of mode comes in then. Now, what is mode? Now, if you thought that mean is the most easiest to calculate, let me prove you wrong. Mode is supposedly the most easiest central tendency value calculated. So what is it? Mode is the observation with the highest number of occurrences, or in statistical term we call it frequency, in the data. The data doesn't need to be arranged. We can identify the mode just by glancing over the frequency for each observation. Consider that there are 10 people and we just go on to add in or take a frequency count of all their uh, customers, or how many customers they go on to add in to the particular company on a for a particular week. So if I go on to say that who got the most who has the highest frequency, it is easy to identify that is it is the person who comes here, the person who has the ID 6. Makes sense, right? Let's look at a different example form. So there were a few people, and they were all asked to check their pockets and take out any amount of change that they had in their pockets. So the one person had 8, 5, 7, 10, 15, 21, 5, 7, 2, 5. These were the values that each and every person had in their pockets. So if I go on to say what is the mode for this particular data, you say that 2, 8, 10, 15, and 21 occur once. So that is okay. But let's see if there is any other value with higher frequency. So we see that 7 occurs twice in this particular data set. Okay, that's better. But is there something better than this? We see that 5 occurs 3 times. So according to what we just learned, just because 5 has the highest frequency, that makes it the mode. Going back to the very same question that we encountered earlier, where the restaurant problem, we go on to see the same data over here. So now we have 3, 4, 5, and 5. Now the median gave us values in decimals, and we cannot have people cut into halves or quarters. So basically, if we take mode, we can just say that, okay, you do one thing, manager, you can have 5 chairs, and if there are people lesser than that, the seats can just be empty. Makes more sense, right? So that's how we have 5 as the best answer for this particular problem. So you see that there is no one particular method that conquers all problems. Somewhere you need to use mean, somewhere you need to use median, somewhere you need to use mode. That's exactly what I wanted to point out through this particular presentation. Now, now that once we are done with mean, median, and mode, let's look at a few terminologies that might come in handy. So we have bimodal here. What is bimodal? So bimodal is nothing but your data now doesn't have one single value with high frequency. It has two uh, values which have high frequencies, like the graph on the right. Let's take a basic example to understand this particular graph. Say that you are a shop owner and you want to see the distribution for your beverages. Now you will have a distribution something like this, showing that there are two particular beverages that are highly in demand, or the demand outrun the others. So generally, you will have tea and coffee running out all the other beverages. Like if you go on to see the consumption of tea and coffee compared to say something as general as say green tea or some other beverage that is common, you will see that tea and coffee is highly preferred, and that's the best example that you can have for this to understand this particular distribution. Now, I've been talking about the bell curve, and you saw the mean and the median, and how do we go about it. But what is the bell curve? Like, we understood the shape of it comes from the bell-shaped thing, but what is it exactly? So the bell-shaped curve basically says that if we go on to take a random group of people, let's take an example to understand this. Let's just say that we take a random group of people from the crowd and you take in all their ages. Now, after making a tally of each and every age, you will have a distribution that looks something like this. So that makes sense. You will have very low number of people with say age of 0 to 5. They'll be kids. Basically, they'll be very people generally do not go out with small kids or something like that. And you will have very low number of people with high values, say a somewhere around 90 to 100. Correct. So the values in the middle, the teenage or adults or just adults, whatever you want to term them as, will have the highest frequency. That makes sense, right? So that's what the bell curve shows us, that the distribution will have as we go towards the mean or the middle, we're going to see that there'll be high number of people coming in this particular section. And as we go towards the ends, the the distribution will have lower number of people towards the end for this particular example. Now we understand something called the skewness. Firstly, let's get these two terminologies in our head. There's something called the negatively skewed data and there's something called the positively skewed data. Now, obviously we got terminologies, but what do they mean? So if you go on to see, the bell shape over here is a bit crooked and has the bell towards the right, and there's a small end that comes out from here. So now let's understand the terms here. So this bell is also referred to as the hump, and this is called the tail. Now, on the basis of the tail's direction, we term the particular shape of the curve. Now, just because the tail is towards the left, we call it negative. It's in the negative direction, and we call it negatively skewed. The opposite happens in positively directed graphs, where the tail is towards the right and the hump is towards the left. You can either remember it from the hump's perspective or the tail's perspective. But in statistics, we generally take the tail into consideration and then go on to describe the particular graph. Now, what happens in this particular graph is, as we saw in the earlier examples, because of the outliers, the mean value gets pulled towards the outliers. Correct? You can see that over here as well. There is some value that is very high and that pulls the mean from the middle. We can see that the median as it is divides the particular data into half for both the cases, and mode over here goes on to show what is the highest value for each of the data, being showing us the peak. Now if you do not get time to plot the particular data and have a visual visual feel of the particular data, what do you do then? Well, there's another way of identifying it. As we can see here, if the mode value is greater than the median and the median value is greater than the mean, it basically signifies that your data is negatively skewed. And if the positive value, if it's positively skewed, you will have mean as the greatest, median being in the middle as well, as usual, and then comes in mode.